How are you, everybody who is watching this video? My name is Olenjolai TAYAI from beautiful, fantastic country, the United Republic of Tanzania. I would like to take this moment to welcome you onto our online Diploma Polytechnic Institute of Tanzania in square bracket Olenjolai. Okay, so basically or strategically in these online schools, we have online institutions. It's not like a physical institution, but we have a visions in these online institutions that we are always that we are working on it, and then that our intentions at the end of this program, we find that we have met that visions, because that is what making this online Diploma Polytechnic Institute of Tanzania to have a meaning in the real life. And the vision is this one, that we would like to prepare or to be a part of people who are preparing a group of Tanzanians, or even Africans, or a group of technicians who are able to combine both the spiritual, the true spiritual knowledge and the scientific and mathematics understanding or knowledge, in order to solve real life problems. So our intentions is not to pass exams. However, that passing exam is a subset of our program. Our intention is to see that our students, our graduate students, who will be taking formal education somewhere in a certain institutions or college or a certain university, but will be supplementing these contents to them in order to help them to make sure that they understand what they'll be learning in the classroom, and to challenge them to take the knowledge and solve the real life problems, because we are born to come and we are born in order to solve problems that has been existing in the planet Earth. It might be one problem which nobody can solve rather than you, or it may be more than one problem. Okay, more than one problem. So that is what is in our mind, and that's what you like also to remind to our students every time. If you're parents, you're guardians, and then you have some of your kids or some of your relatives, such as your uncle, who is doing diploma programs in engineering and in scientific courses. So this is a fantastic program for him or her, because we'll be using different teaching techniques and different teaching aids and different teaching approach and different teaching methodologies, right? On teaching mathematics, scientific and engineering, basic scientific and engineering mathematics, and even also later on we'll be teaching our students about computer programming. And that's not enough. Also on the 30 phase of this program, we are going to teach our students about basics of electronics engineering, basics of telecommunication engineering, basics of electrical engineering, basics of computer engineering, basics of biomedical engineering, and even basics of computer programming. That's what we'll be teaching them. So stay connected. However, that in this online school at the moment when we are recording this lecture, we have only one department, that's departments of basic engineering and the scientific mathematics. So, but stay connected. Okay. So that is the piece of information that I wanted to share with you. This material might be useful to any student or any hobbyist in mathematics that worldwide, in African continents, in Europe, in America. However, that our focus will be focusing on the syllabus and curriculum of United Republic of Tanzania, and the many institutions or colleges or universities that providing technical education. We think that they are under one of the authority in Tanzania called NATE, National Council for Technical Education. So we are preparing technicians, and we challenge them to think differently in order to have a solution of particular problem. So then I would like also to introduce to you our YouTube channel that's called Online Diploma Polyinstitute. Okay. So let me do minor correction here. These three letters are not there. Polyinstitute. So this is Polyinstitute is the abbreviations of this of three words. This is Institute of Polytechnic is so the two words. So poly, abbreviations of Polytechnic, Institute is a abbreviation of Institute, right? Of Tanzania, in square brackets, Olenjolai. M is not there. M is for our other YouTube channels, right? So M is not there, so don't confuse, because sometimes you might be searching for this one. So in order for you to get there, first of all, you have to make sure that you have an official email, and then you should also subscribe onto our channels. And once that, how do you subscribe? You should sign in YouTube, okay, software, and then after you sign in, then you may come and click these buttons which has been written subscribe. Then once you click it, it will change color and the writings will become gray, while the backgrounds is becoming white. Once you subscribe, right? You click these buttons and subscribe, a bell will appear. Just click this bell once, and then you'll see 3 options: all, personalized, none. So choose all. So once we upload, we are going to upload more than 100 videos onto our YouTube channel supporting Diploma of Online Diploma Polytechnic Institute of Tanzania. So it means that once you subscribe, then the YouTube community will give you information once we add a new video. Okay, so that's another piece of information. Again, we have departments of basic engineering and scientific mathematics. So when we say that basic engineering and scientific mathematics, maybe we have a higher engineering and scientific mathematics undergraduate. Also, we have another school or another institution that's called Online Undergraduate Polytechnic Institute of Tanzania. Then the module course is called Algebra. Year of study is first semester or first year, right? First semester or first year. Okay, so let us go to the session. So we have lecture or lecture 2, introductions of indices. That's what I'm going to teach you. But before I take you there, let us let me connect our previous, my previous lecture with the present lecture. Okay, so refer I would like just to share with you a quick review of lecture 1. So in lecture 1, basically that we have introduced it to you about, first of all, the topics that we are going to teach you, topics of algebra. So how many topics did I mention in total the year 7? 2 topics are from Boolean algebra, and 5 topics are from ordinary algebra. Again, we define what the meanings of the word algebra. Very interesting. It's a branch of mathematics that deals with mathematical symbols and the rules that manipulating those symbols are the definition. Again, we discussed, or I told you about classifications of algebra. So we have 2 main branches of algebra, or 2 classes that we say that the first one we call it ordinary algebra, and the second one is called what? Boolean algebra. Okay, Boolean algebra. Okay, so again, we went in detail. I told you for ordinary algebra, but finally also I told you about branches, and I left your homework for you. Branches of ordinary. However, this ordinary is just called of algebra, right? Ordinary algebra, but shortly called algebra. And you said how many branches? They have 5 branches, right? Communicative algebra, abstract algebra, and then you have what? You have elementary algebra, advanced algebra, and also we have you have elementary algebra, advanced algebra, and then you have linear algebra, and then you have communicative algebra, and the 4th one. So then we took you and just defined to you what the means of Boolean algebra. Very interesting subject. Define it, just that you want definition. Please watch lecture 1. It is still in our YouTube channel, so you can record what will be discussed. But I guess that you say that in the Boolean algebra, we have different notations in mathematics. Okay, so you have to understand them. For example, that Boolean operations are this conjunction, disjunctions, and the not. So in digital electronics right now, so in digital electronics you say that this one we call it AND gate, and this one we call it OR gate, this one we call it NOT gate. Right? So that's what we have been discussing with you. So today, let us go and make sure that in case if you want too much details about it, go to lecture 1 of algebra in our channel. So today we want to introduce to our students about indices, which is one of the contents of algebra for the ordinary diploma NTA level 4. So indices, this is not a new terminology for the senior students. It's an oldest terminology. Fortunately, you haven't known that it's called indices, but it's very important terminology. So let us start with the question that what is indices? Index, or what is indices? Okay, this is the first question for this page. What is index? What is an index or indices? And the question that we have. Excuse me. Indices or index have the resources defined like this. That is the power or exponent which is raised to a number or a variable. So you say that indices or index is the power or exponent which raises to a number or a variable. That the means of index is the power or exponent which is raised to a number or a variable. Or an index An index is the power So an index or a power, so I was checking it well. An index or power is a small floating, just a small floating number. Small floating number that appears after a number or letter. So you say that index or power is a small floating number. The small floating number that appears after number or letter. In addition to this sentence, you say that indices show how many a number or a letter has been multiplying. By itself. So an index is a power, is a small floating number that appears after a number or a letter. And also say indices show how many a number or a letter has been multiplied by itself. So what does it mean about indices, right? So for instance, as examples of indices, you have 2 power 4. This is an index. 2 is base and 4 is exponent. So this is what you call an index. Next can have x squared. So that's an index. X is base, 2 is power or index. Then here it is y power 3. Similarly, it's an index. For instance, also you can have x plus 4 power 1/3 as an index. Okay? So these are the sample examples of 40. So these are index, base, base. Okay? Again, another thing that we have to for instance, for the indices, this we call the base or exponent. So if you have, for example, a power m, and we say that a, this is equal to base, and m, this is equal to exponent. I believe that in case you are watching this video, please subscribe, for you to receive notifications for any new video. Right? So this is base, and this is exponent. Afterward, we'd like to teach you the next concept that we call the laws of indices. Laws of indices. Say laws of indices. Say laws of indices. We have some laws that you have to follow when we be dealing with indices. There are some laws that are useful that are useful on performing operation of indices. So the first law is this one, that we say that before you write this law, you say let A and B be the base, be the general base of of exponent or of expression. Base of of expression. Then we say that let M and N to be the exponent. Exponents of 40 of an expression, right? So the first law, when you have A power 0, it means base power 0, or any number power 0, any letter power 0, the answer is 1. Similarly, even if you have B power 0, the answer is 1. Even if you have 3 power 0, the answer is 1. The first law. We go for the second law. Second law, we say that if you have A power M, open bracket, close bracket, times N, this is equal to A power M times N. Go for the third. I want to simply begin with this simple formula. Okay, the other simple expressions, we say that, remember that even this one also is equal to A power M times A power N. Another expression that, for instance, that you have A power M. And then we say divided by what? A power M A power M divided by B power M. Answer is equal to what? A power B, A over B power M. We go for the first rule, which is common. In case that you have M, so A power M. So A power M, we say that, okay, so then we say that you multiply with A power M. This is equal to what? So this will be equal to A, because the base is common, power m plus n. So it was A power m times A power n. Same base but different indices. So there we have the same base, which is A, but we have different indices, which have different index. You have index m and index n. So it means that this one we say it is A power m plus n. So that is in terms of in terms of indices. You have to be careful there. Then the fifth rule is about division, right? Had several of the plan. Division. So division says that in case that you have A, for instance, say that you have A power n, and hence divided by A power n. So it means that you're dividing the exponent is the same base, right? The same base. So we say that this one is equal to what? A power m minus n. A power m over A power n is equal to A power m minus 1. Okay, I believe that you're enjoying the beauty of basic engineering and scientific mathematics, right? Tell me in the comment sections if you enjoyed it. Okay, so you have again the sixth rule. The sixth rule states that if you have A power m over n, this is equal to what? Guys, so this is equal to A power m over n. This is equal to what? A power 1 over n, and then multiplied by n. Right? So this will make what? So this will make it the nth root of A. So again, we say that power m. Right? So we say that A power m over n, this is equal to what? Is equal to nth root of A power what? Power m. Power the seventh law. If you have any question, don't hesitate to ask in the comment section. Again, we have against this is the law, we call it the law of nth root. That is, this is the law of division or quotient. This is the law of product. Don't worry about those names. The issue is, are you competent so you can solve? So A power 1 over m, right? So what does it mean? This simply will be similar if you have m here, right? And then say what? A. Okay, so this is what an expression. So A power 1 over m is equal to the nth root of 40 of A, right? Okay. Again, the x root or the x law, we say that for instance, A power negative m. So these are the way that we used to treat under this condition that, let's just introduce to that we have A power negative n. What is going to happen? That's the question. So if you have A power negative n, then we say that, well, so this is equal to what? This is equal to 1 over A power n. Right? So that's what we say. So we say that, yes, that's the one of the law. So you can add up some more laws as well as you can. But for me, I found 8, and hopefully, I might think that they are open in your mind. So let us now go to problem solving. And this the subtopic, because that was general introduction support of indices. So this one we say that is 2.3. 2.3. So 2.3 say that because I have talked about laws of indices. So 2.3 will be what? Will be the concept that we call the simplification. Simplifications, because our aim here to simplify the algebraic expression. So simplification of simplifications of what? Of problems. Problems in what? Of problems. Simplifications of problems in what? Of indices. Of indices. So what can we say that? An expressions of indices, we can just simplify it in case we've been given, or in case that we given some expressions and you apply these laws of indices to simplify until it becomes simpler and simpler. So let us look now at the first example. So the question is simply simplify. What should you simplify? This expression. One plus x or half minus a half x okay, so we say that 1 plus x power half minus a half x open bracket 1 plus x power negative a half, and then the entire expression we divide with denominator, which is 1 plus x. So this one is power 1, because that's what it has been written. Okay, so you have a problem there. Aims, or we've been asked to simplify. So remember that I would like just to remind you that the process of simplifying an expression depends on how we can simplify until it becomes simpler and simpler and simpler. So in order to simplify, we have to use also laws, these laws that are very important. So we say solution. Okay, solution. So the first state, we say that you have our expression there. So the first step we say that express, or let us simplify expression. Okay, so to simplify, what do we say there? First of all, 1 plus x power negative a half. Okay, this one is equal to, according to the what? to the log. But you say that a power negative n. This is equal to a power. This is equal to 1 power a power n. Okay, so if this is the case now, we say that 1 plus x power negative half. This is equal to 1 over 1 plus x power positive half. So instead of this expression here, we are going to do this issue. So go for the second step. Second step. So second step, we say that you have 1 plus x so this is power half minus x over 2. And then we say that there we have what? 1 so minus h over 2. Then as we said here, after simplifications, it's going to be 1 over 1 plus x squared. Is it? No, per half. Okay. So there we have x plus what? Plus 1, right? So then the next process now, we have to find 40. So simply this one, which is one number, needs to put into 1, right? So as we say, the numerator of 1. And then we say that if we find LCM there, with these expressions and that ones, that will be at 1 plus x power 1, or power to power half. Okay, power half. So then we take this one over 1. So we get that 1 plus x power half multiplied by 1 plus x power half. Right? And then say minus. Minus what? Minus h over 2. Right? Minus h over 2. So minus h over 2. And then we say that we divide with what? With x plus 1. To simplify further, these are the same base. Exponents of what? Indices of the same base. So you add the exponent. So it will be 1 plus x power a half plus a half. Right? And then we say that minus what? X over 2. Then you have what? You have x plus 1 times what? Times 1 plus what? 1 plus x power half. Okay? Power half. So what do you say here? So the numerator will be equal to x plus 1 minus what? X over 2. Then the denominator we have what? X plus 1 power 3 over 2. Okay, so if that's the case that you say fine, so this is equal to x over 2, so that was okay, and then over that 2. Okay, so what? So if this is the case, you say that if you simplify the opening in the bracket to be x over 2 plus 1 divided by x plus 1 power 3 over 2. So it is x over 2 and that one, so x plus 2, okay, and then you have 2. So then we keep on simplifying of our expressions at x over 2 plus 1. So we have x over 2 plus 1. And then say that you have known which is x plus 1. So then if we simplify these expressions, the numerator there, LCM is 2, so we have x plus what? 1. And then in the denominator we still have x plus 1 power 3 over 2. So this is x plus 2. So simply say that the entire expression, which was 1 plus x or half, as x over 2, 1 plus x, 1 plus x, and this is 1 plus x power negative a half. Divided by 1 plus x. Then this is equal to what? So what you've got there is x plus 2, and then it's 2, x plus 1, 3 over 2. 3 over 2. So this is the final response of that expression. Is it interesting? Is basic mathematics interesting to you? So let us do the second example. Then I'll leave the homework for you. Okay, so get prepared for the second example of this concept of algebra so that you may enjoy it perfectly. Okay, so let us proceed with the second example of indices, or introductions of indices. Of course, we did the first example and then we simplify this defined expression. Okay, so according to what we've been finding about. So let us do the second example, which is a little bit challenging. So this is the example 2. Then I'll give you example 3, and the example 4 will be the homework for you. So this is the little bit concepts, because we also need some concepts of quadratic So the question is that solve for x. And which expression should you solve for x? This is the constant 4. And then say 3 to x plus 1. And then say plus 17. And this is 3 power x minus 7 is equal to 0. Okay? So the question asks us we have to solve for x. So we have 4 times 3 power 2x plus 1 plus 17. Then open bracket, close bracket, 3 power x minus 7 is equal to 0. So you have to enjoy the beauty of basic engineering and scientific mathematics. So solution. So we are going to use laws of indices. Okay. First step. So the first step, because our aim we want to solve for x, we say that simplify. Simplify the question above. By using what? By using laws of exponent or indices. So where can we use the law of indices? Good. So the first one, if you do remember that we said if you have a power m plus n, this is equal to a power m, then we multiply by a power n. So if that's the case, for instance, this part, this is 3 power 2x plus 1. This is equal to 3 power 2x, and then we multiply with 30 with 3 power 1. Okay, so at least we've simplified it. So if that's the case now, so we say that suppose that this is the first equation. So we have 3 power 2x plus 1 is equal to that one. So suppose that this is the second equation and this is the first equation. So you go for the second step. Second step, you say that substitute equation 2 into equation 1. So we substitute equation 2 into equation 1. We have 4 and 3 power 2x, then times 3 power 1, and this is plus what is 17, 3 power x, and then she said minus 7, this is equal to 0. So 3 power 1, this is the constant number, so 3 times 4, this makes 12, then I have 3 power 2x, and then plus 17, 3 power x, minus 7 is equal to 0. Okay? So you have to enjoy the beauty of engineering, basic engineering mathematics, and the basic scientific mathematics for the diploma. So then, so if this is the case now, we say, okay, fine. So we have our expressions now, our new equation, which is 12, 3 power 2x, and then you have what, 17 plus 17, 3 power x, then minus 7 is equal to 0. So what can we notice there? So the thing that we cannot see is, also we can keep on simplifying that we can say that 3 power 2x, this is equal to 3 power 2, then we multiply with 3 power x. Right? So 3 power x. So in other words, also you can say that this is equal to 3 power x, and then we have 2. So if that's the case, we say that here we have 12, and then 12 we have 3 power x, at power 2 plus what, 17, and then say 3 power x minus 7 is equal to 0. So then we have to think again, how can we solve for x? Because our objective is to have to find the value of x. So you have to think differently so that you can get the value of x without too much of hassling. What do you suggest? What can you do there? Pause the video and then try to think yourself. And so continue the video. So we go for the steady state. The steady state, we say that let y is equal to 3 power x, or let 3 power x is equal to 1. So afterward, we are going to have 12, okay? Then here we are going to have y squared, then plus 17y minus 7 is equal to 0. So this will make it 12y squared plus 17y minus 7 is equal to 0. So now we have formulated a new quadratic equation. So we have to solve for y first. When we get the value of y, we come back onto this equation. So suppose that this is equation 3, and this one, it is equation 4. Okay, equation 4. So then, this is equation 5. Equation 5. So, if that's the case, what do we say that? We say, okay, fine. So we say that you go for the first state. The first state, we say that you can use either scientific calculator, or you can use a game of formula to find the value of 40 of y. So let us simplify the life. So use the scientific calculator. Use the scientific calculator to find the value of y. Okay, so you can take your beautiful scientific calculator, guess that you have it. So you have to take your beautiful scientific calculator and compute the value of y. So you just press mod. Okay, press mod for the first time, second time, third time. Then you go for the equation. How many unknowns are there? None of them. You press this part of the display to the degree. How many degrees do you have? 2. So you choose 2. A is what? 12. B it is what? 17. C it is what? -7. So the answer x1, y is equal to 0.33. So you can put in fraction. It's 1/3. And then the other one is negative. The second value of y it is -1.75. So then we say that the first value of y is 1/3. The second value of y it is -1.75. So next, we always prefer the positive value of y because sometimes it's a little bit difficult to find the square root of negative number. Because we know that we can find the square root of negative number, which the answer will be a complex number because it will contain the imaginary part, right? But we are trying to simplify our life. So then, so if this is the case, we say that we go for the fifth step. The fifth step, we say that substitute y is equal to 1/3 into equation 4. Into equation 4, so you can find the value of x. Okay? Okay. So then we say that we had the y is equal to 3x. So you can say that now 3 power x is equal to 1/3. So this one, according to the laws of exponent, that we say if you have 1 over a, this is equal to a power -1. Similarly, 1 over 3, this is equal to 3 power -1. So we say that 3 power x is equal to 3 power -1. This is according to the law of indices. Same base, so you cancel the base, and then you find that the value of x is equal to -1. So this is the final response. Okay, final response. So the final response, the value of x for that situation is equal to -1. Okay, so let us do something else before we end this session. So Shift T, or we have what we have, -2 plus 1, so it's -1, so we have 3 per answer, and then 6 times 4, and then 6 30, 17 over 3, and then it's -7. Yes. So you can also prove, but that is for just for the proof. You can prove. Right? So you can prove that. Proof if for 3 twice x plus 1 times plus what? 17, 3 power x minus 7 is equal to 0. Is equal to 0 when x is equal to -1. So substitute it, the answer is true, to be equal to 0. So then we conclude that that's a response for that question. So try to look for other more questions of this format so you can solve and enjoy the beauty of engineering and scientific mathematics. So let us go to the next example. And this is, I will leave the homework for you so you can try, because I know that you can solve it. This is homework 2, because this is for lecture 2, right? So homework 2. So the question asks you to simplify, not to solve. Many questions of indices and logarithms will be asking you to simplify or finding the value or solving. So you should be familiar with this perspective. So you have 1 minus x, okay? 1 minus x. And then we say that we have times a half. And then 1 plus x. Negative a half, negative a half, plus a half, okay, plus a half. Then we have 1 minus x, then power negative a half, and then square root of what? 1 plus x. Then this one, we say that we have 1 minus x. So square root of 1 minus x, a half, open bracket 1 plus x power negative a half, plus a half, then times 1 minus x, minus power negative a half, then times square root of 1 plus x over 1 minus x. So simplify to the maximum level where that we cannot simplify further from that point. So make sure that you do that, and then you enjoy the beauty of engineering and the scientific mathematics for the diploma students. Okay, so this is all about the session 2 or lecture 2 of Introductions of Algebra. As I said that I'm going to introduce to you the concepts of indices. So join me in the lecture 3 of, also I will teach about introductions of logarithmic in a different perspective from what you've been learning during the O level, because we know that during your honor level you have learned about the exponent and the topic is called exponents, which is Form 2, and logarithms also, which is in Form 2. So however, so what are we going to do in diploma level? So it means that we are going to build on the fundamental foundation that you have in your mind. So that's what we are going to do. So join me the next few sessions. I thank God to have been with me in this session. And also I thank you for taking your time and being with me and even praying for me. So may God bless you, and make sure that you subscribe onto our YouTube channel so that you get notifications once we upload a new video. And you have to get prepared to love engineering and the basic scientific mathematics for the rest of your life. So stay safe and join me in the next session. May God bless you abundantly.